So here we have a vector airplane problem where you're given the magnitude and direction for an airplane and for some other type of vector like the wind, and you want to figure out how fast these things are being affected. So the first thing we do is we start off by drawing your compass. Remember, for airplanes, 0 degrees is due north. So if I'm flying at 215 degrees, that means that is about this much. 215 degrees goes this way into the third quadrant, and it has a speed of 550. And the other one, wind from the east, which means the wind is blowing to the west, so the wind is blowing this way at 55 miles an hour. What is a plane's course and ground speed? So we do this by making a parallelogram. We'll put the wind down here at the tip of the airplane, and we can complete your parallelogram with this one here. So always the resultant is going to be the line that goes from your origin out here to where your wind and your airplane meet. So this is what the plane will be doing once it is affected by the wind. So it looks like it's going to be going faster and a little bit more to the right. So we have to do some investigation so that we can use, well, let's use the law of cosines. It's easiest here. So in order to that, I need to figure out what this angle right there happens to be. Okay, so let's zoom in real fast so we can talk about this. So 215 is to here, and this is 180 degrees. So this is 35 degrees right there, which means the rest of this is 90 minus 35 degrees, which is 55 degrees, I hope. Okay, so because this is a parallelogram, this 55-degree angle and this angle here have to be supplementary because they are consecutive interior angles. So 180 minus 55 gives me an angle of 125. Okay, so now zoom back out. And if that angle down there is 125, that means this angle right here is also 125. And that's the angle we're going to use for our law of sines, or law of cosines problem. I can't erase that. So according to the law of cosines, the resultant is equal to 550 squared plus 55 squared minus 2 times 550 times 55 times the cosine of, in this case, 125. Okay, it's really important to know that if we're trying to find this blue side, that we have to use the measure of the angle across from it. So whatever side we're trying to find, this is the angle that's across from it. Okay, so we put all this into your calculator, you take the square root of it, and you get out approximately 583 we'll call it 0.3 miles per hour. So that's the ground speed of the plane. That's what it looks like the plane is flying to somebody on the ground. So the next question is, what is the course? So we have to find an angle, and the angle we're looking for is going to be this one right here. Because if I can add this, find this angle, I have to add it to 215, and that will give me the course of the plane based upon true north. So I'm going to try to find that angle right there using the law of sines. So the law of sines says if we take 55 and the sine of that angle, that should be equal to, I'm going to use this blue one, 583.3, divided by the sine of 125. So you always have to use the side and the angle opposite. So because I know this now is 583, I know this angle, I can figure out this other one. So cross multiplying means my angle is going to be the inverse sine of 55 times the sine at 125 divided by 583.3, and that gives me 4.4 degrees. And like I said before, that's just this little red angle right here. So this red angle is 4.4 degrees. I have to add that to my 215 degrees, giving me a final angle of 219.4 degrees is my course of the plane. So when the wind is blowing along an easterly axis or a westerly axis, it's easiest to use the law of cosines to figure out the resultant, and then use the law of sines to find that angle.